Example 5, we've been given a point 3, 5 on the graph of y equals f of x. Now, this graph given here, it's important to recognize that this is not f of x. This graph is f prime of x. Okay, so this is y equals f prime of x. So this is a derivative function. And it says, what is the equation of the tangent line at point 3, 5? Well, for a tangent line, we need slope. And we're going to get that from the derivative function, so the f prime function that we have over to the right. And we also need a point. And that point we're going to use is a point that was given. Okay, so this is a tangent line to the point of f, and so we need a point on f. So when I take a look at the slope, I need to have slope at x equals 3. So I need f prime at x equals 3. So when I take a look at this graph, there's 3, there's the y value is equal to 2, so that means that the slope is equal to 2. Once I have the slope, I can then write the equation of that tangent line. Y equals slope 2, and then the point is going to be at x equals 3 and y equals 5. Okay, so there's the equation of my tangent line. I get my slope from my derivative. I need to recognize that the graph given is the derivative graph. And again, I'm going to make sure I highlight that. The graph of the derivative is given. So from that graph, the y coordinate gives me the slope, and I can plug in the x and y coordinates to get the point. So there's my point slope form of that tangent line. For this next one, it says the function has a coordinate at e and 3. So again, I've been given a point, and that satisfies the differential equation dy over dx is equal to 2 log x. What is the linear approximation of the function at x equals 3? So in this case here, we've been given the slope equation of the derivative is going to give us a slope. We have a point. So all we need to do is calculate the slope, and then we can come up with a linear equation. And that linear equation will approximate the function. Okay, so the first thing I'm going to do is at e and 3, I'm going to calculate my slope. So the slope dy by dx at the coordinate e3 is going to be equal to 2 times log of e. Okay, that's going to give me a slope of 2. So that's going to be the slope of my tangent line. I have the coordinate, so I now have the equation I can now come up with the equation of my tangent line. So I'm going to call this L of x. This is my linear approximation line, and it has a slope of 2 and a point at x equals e and y equals 3. Okay, so there's my linear approximation line. And this line is going to approximate values on the original y equation. So I want to approximate the y value at 3, and that's going to be approximated by the tangent line approximation when I plug x as 3 in. So when I do that, I get 3 minus e, 2 times 3 minus e plus 3. So this tangent line gives me a coordinate at 2 times 3 is 6, plus 3 is 9, and then 2 times e is 2e. So at 9 minus 2e, I'm going to have my coordinate. So this coordinate, this y value, approximates the y value at x equals 3 on the original function.